So hello everyone. Now we are going to be discuss Poisson's ratio and relationship between stress and strain in the subject strength of material. And my name is Dr. Ishad Ahmed Khan, Associate Professor in Department of Mechanical Engineering, Sagar Institute of Research and Technology, Bhopal. So let's understand this concept, Poisson's ratio. So this is a ratio of, you can understand simply, ratio of lateral strain to the longitudinal strain that is equal to the constant for any given material. This ratio is said to be a Poisson's ratio, and we can write this. So let's understand longitudinal and lateral. What is the lateral and longitudinal strain? So when a body is subjected to the axial tensile load, there is an increase in length of body. But at the same time, the other dimensions of the body was changed at the right angle to the line of action of applied load. Thus, the body having the axial deformation and also deformation at the right angles to the line of action of the applied load. That is called a lateral deformation. So, simply you can understand here, dear students. So, once you are applying the load along the length, that is, it will give you the longitudinal strain. And in the right angle to the applied load means this direction toward the diameter. There is also some change in dimension. So which strain we will obtain along the diameter, that is called the lateral strain. So here we can calculate the longitudinal strain. Strain is change in length upon original length. What is change in length? It is del L. Original is L. You can see here. Okay. So and for the how to calculate the lateral strain, simply the change in diameter in perpendicular to the applied load direction or toward the diameter direction. So del D upon D. So lateral and longitudinal strain once you calculate and that just divide to lateral to longitudinal, we will get the Poisson ratio of any material. So simple is this is a simple numerical. You can make a better understand of this particular concept of the Poisson's ratio. So this simple, a bar of 24 mm diameter and 400 mm long length is acted upon by axial load of 38 kN. Elongation of the bar and change in diameter are measured. So elongation, the change in diameter toward the length and toward the diameter is given. So change in length is given. Okay. So respectively determine the Poisson's ratio. Let's simply. So we have the change in length. We have 0.165. This is, and the length of the bar is given 400. So divide this, and we get that longitudinal strain. And similarly, lateral strain we can calculate this upon the diameter is 24 is given. So this and the Poisson's ratio lateral is this one upon this. So this 0.313 is called Poisson's ratio of the given material. Let's understand the concept of relationship between the stress and strain. So if the applied load is a one-dimensional case, it is applied on the long bar where the length is quite higher than the second dimensions is compared to this diameter. That's called one dimensional case. So here sigma is equal to E or small is, where E capital is the Young modulus and small is the strain. And two-dimensional case, it means when a two-dimensional body are subjected to the load in the both direction, in two direction. So suppose we have taken a cube, but we have given the loading in two dimension. As mentioned in the diagram, we can see. So we can calculate the strain along the x-axis due to the stress produced in x direction sigma s is equal to, simply we can say sigma x upon E. This relation is came from the Hooke's law. And similarly, the strain along the x-axis due to the stress produced in y direction. Okay, so to the is this load which is acting on y direction, this x1 is act as a lateral strain. So we can write is minus mu sigma y upon E, and the total strain in x direction would be Ex, this one minus this part. Okay. So similarly, the total strain in y direction, you apply the same concept in the y direction. It would be like this. So these two equations can be used to calculate the strain in x direction and y direction in the two dimensions. So similarly, we can apply the same concept for 3 dimension. This is a cube, and all 3 direction x, y, z, some load is applied. Due to the load, some stress is produced, and due to this stress, there must be some strain. So strain along x direction due to sigma x is sigma x upon E is the Young modulus, and strain along x direction due to sigma y. Similarly, strain along the x direction due to sigma z. That old concept what we have applied in 2-dimensional case. You hope you are understood. So that is minus mu. Mu is the Poisson's ratio. Minus is because it is in the compressive nature along the lateral direction. Okay, so that wise is coming the minus side. So this terms and this term whole you just add. So this is the total strain in x direction sigma x. C is the Ex is equal to sigma x upon E minus mu sigma y upon E minus mu sigma z upon E. Similarly, the total strain in y direction and total strain in the z direction we can calculate. So you might be understood, if I'm talking about the x direction, so first the x term will come, this sigma x upon E, and the next two term it will become with the Poisson's ratio. Okay, this is the Poisson's ratio and minus sign because they are compressive kind of. So thank you so much for listening this lecture. Hope in future we will be discuss more concept of strength of material.